Hello again, dear grade 8 students. After talking about the shaded area, after finding the shaded area, let me review how to prove a square using its diagonals. So I'm going now to join the midpoints of the opposite sides and the adjacent sides together. So as you see, I'm joining that midpoint to that one, and to that one. What's the shape I'm getting here? It is definitely a square. So we need to prove it a square. To prove it a square, I have to think what I should use. I have to use either diagonals that are or that should be perpendicular, equal, and bisect each other, or I have to use that sides, all the sides are equal, and there is a right vertex here. Now, according to the first idea, using the diagonals is better and easier. So I can simply join the diagonals, and I can notice that these diagonals are equal. Why? Because they are diameters. As you notice, they are diameters of the same circle. So definitely these diagonals are equal. They bisect each other simply because if I name the points here, for example, K, here for example M, N, and L, I can notice that these midpoints K, M, N, and L are on the circle. They are points on the circle. Then EK, EM, EN, and the L are radii. And because they are radii, then they are equal. And by this, we can say that the diagonals bisect each other. I have that these pieces are equal, and by comparison, I can notice that all of these segments are equal because they are radii, and as I told you, Kn and Lm are equal diameters because they are diameters of the same circle. We still have to prove that these diagonals are perpendicular. If you notice, Kn is parallel to AB or is parallel to CD. So Kn is parallel to AB, Lm is parallel to BC or parallel to AD. But now if I take BA and BC, they make a right angle because, as you know, the vertex of the square is right. So those parallels, Kn that's parallel to AB and Lm that's parallel to BC, will definitely make a right angle. They have to be perpendicular because parallel to perpendiculars are perpendicular, and thus we proved it a square using diagonals. So let's write what we said. First of all, we have to say that EK equals EN and EM equals equals EL, and because they are radii of the same circle. That's a little revision for the circle. Also, we say that the diagonal LM is equal directly to the diagonal KN because they are diameters also of the same circle. We just need to prove them perpendicular. As I told you, we say that Kn, I'm going to choose AB is parallel to AB and LM is parallel to BC, but AB is perpendicular. So I can write it like this, to BC. Then definitely I have to conclude that Kn is perpendicular to the other diagonal, which is Lm, and the reason is that parallels to perpendiculars are perpendicular. Okay. And thus we say that KLNM, so KLNM is a square by using the diagonals, since its diagonals that are named LM and KN are what? Are satisfying the three conditions: perpendicular, bisect each other, and equal. That's according to proving that inscribed square in a circle, or that inscribed quad in a circle, a square. Now let's talk a little bit about the area. Let's make a little revision, a final revision for the area. I need to find or to compare. Let's compare the areas of the squares ABCD and KLNM. Now, according to ABCD, the square of ABCD, definitely we are going to use this side because we know this side. So it is 4 power 2 because I know this side, which is 16. So I just have to put 4 here. So it is 4 power 2, which is 16 centimeter squared. And according to the area of KL and M, it is equal to, here I can't use this side for KL and M unless we take Pythagoras later. So here we are going to use the diagonals. The diagonal KN is 4, or the diagonal LM, and we use the property of D squared over 2, which is equal to, so D squared over 2, which is equal to 4 squared, which is 16, over 2, which is 8 centimeters squared. And thus, we notice that the area of ABCD is twice or double or 2 times the area of KLNM, or we say that the area of KLNM is half that of ABCD. So we write the area of ABCD is 2 times the area of KLNM, or we write that the area of KLNM is equal to half that of the area of ABCD. So we can write it both ways. Now, a final note, what do we call E, that point here? E is a common center for the circle. So it is a common center for the circle for square ABCD and for square KLNM. So that point E is a center for the yellow circle. It's for the big square ABCD and for the small square KLNM as well. For the squares, it's the center of symmetry. For the circle, it is the center. Hope you enjoyed this exercise, and we'll meet later inshallah in more and more training exercises. Thank you.